Let's start with loading the media. This is a pretty simple operation, but there are some tricks worth taking note of. To make loading material easier, the tool head and Y bar need to be moved out of the way. Generally, we could use the arrow keys to do this, but the best way is to use the View option, which will move the tool head all the way to the upper right-hand corner. While in Ready status, pressing the 1 key activates the View mode. Once the Y bar is completely out of the way, media can easily be placed. When placing the media on the bed, position it so that it is closest to the control panel in the lower left-hand corner. The FCX2000 is equipped with a redesigned table where the vacuum holes are closer together, providing stronger media hold down. For smaller objects, it sometimes helps to place an additional larger sheet over your design to ensure stable suction. Once the sheet is placed on the table and correctly positioned, press the vacuum pump pedal switch to activate the vacuum, and then press the 2 key for Home to bring the tool head back to the origin. If you are using a roll of media, take the roll of media and place it onto the media stock roller, and place the media roll and roller bar back in place. Pull the edge of the media from the roll. Carefully thread the front edge of the media under the Y bar, and pull the material across the table. Once it reaches the other side, activate the vacuum pump using the pedal switch. There will be times when the tool head height will have to be adjusted according to the thickness of the material. This is generally done when switching between materials that have a significant difference in thicknesses. You'll have to make this determination yourself, but cutting operations may be affected if the head height is not set correctly. To raise or lower the tool head, first move the tool head toward the middle of the bed. Next, loosen the 2 side screws on each side of the tool head using the supplied hex tool. Once the screws are loosened, lift the head and place the block spacer that was supplied with the unit under the tool head. Lower the tool head onto the block, making sure that it's flat against the block. Then tighten the screws and remove the orange block. Next, locate the blade holder you plan to use and remove the cap, exposing the tip of the blade holder. Remove the brass tip chuck from the blade holder by unscrewing it counterclockwise. Locate the CB15U container. Carefully remove the blade from the container and remove the plastic cover. Insert it into the blade holder chuck as shown here. Screw the chuck back onto the blade holder. Extend the blade to the thickness of the media. Place the blade holder tip next to the media you plan to cut. This should give you a general indication of how far to extend the blade. Further test the length by test cutting a piece of the material you plan to use by laying the material flat on a table. Then, with the blade holder tool in your hand, draw a circle on the material. As you're drawing the circle, make sure the tool head is in a straight, upright position and not at an angle. Remove the circle. It should come out relatively easily. If it is difficult to remove, then extend the blade by turning the adjustment knob 1/4 of an inch clockwise and repeat the test. If you are cutting media with a carrier sheet, reach on the backside of the media or vinyl, and with your hand try to push up from the backside of the media under the cut circle. If it pops out easily, then the blade is extended too far. Retract the blade by turning the adjustment knob 1/4 of an inch counterclockwise and repeat the test. Method for checking materials without a backing, such as chipboard or corrugated packaging material, is to place the blade at the edge of the material and cut it. If it splits easily, then the blade is adjusted correctly. Once the blade is extended properly, loosen the tool holder screw enough so that the bracket is out of the way, and insert the blade holder onto the tool holder mount. If this is not done correctly, the blade will not reach the media. Then tighten. Graphtec offers several tools for cutting, creasing, and plotting. If you are wondering which one to use and their respective settings, you can download a tool list from Graphtec's e-commerce website at www.graphtecAmericastore.com. Two of the accessories provided with the FCX2000 are a pen holder and fiber-tipped pen. To use a pen, first loosen the lock handle by twisting it counterclockwise. Next, take the fiber-tip pen that came with the cutter and insert it into the adapter. Then retighten the lock handle. Next, insert the adapter and pen into a tool holder the same way that a blade holder is installed. Generally, tool holder 1 is preferred, especially when a cutting or creasing tool is also being used. Once again, push the pen adapter all the way down until the rim is completely seated and is under the top of the bracket, and tighten. One great feature of all Graphtec cutters are the utilization of conditions. A condition is a plotting cutting preset that can be configured for a specific type of material or job. For instance, condition 1 can be configured for drawing with a pen, whereas condition 2 may be configured for cutting, and condition 3 can be configured for creasing. One cutting condition may be set for cutting sandblast, while another to cutting reflective material or chipboard. Conditions can even be configured to a specific type of cutting. For instance, while condition 1 can be configured for cutting sandblast, condition 2 can be configured for intricate cutting of sandblast, perhaps requiring slower speeds around the corners. The FCX2000 has 8 cutting conditions. Each condition has 4 main settings: tool type, speed, force, and acceleration. There are other settings as well, such as Tangential Mode for cutting cleaner corners on thicker materials. Since there are 2 tool holders, each condition is assigned to either tool holder 1 or tool holder 2, depending on the operation. Recall that tool holder 2 has the higher force of 1 kilogram. This means that certain conditions configured to cut thick or rigid materials may have to use tool holder 2. Let's first take a look at how to configure and test a condition, and then how to switch between conditions. The control panel display will show us information at a quick glance that we need to know. For instance, right now the cutter's display shows the current condition. Just below the condition number are the condition settings of the current selection. So right now, condition 1 has the tool type of a CB15U blade. S is the speed, which is 40 centimeters per second, referring to the speed when the pen is in the down position. F is the force, which is set to 38, relating to how much downward force the tool exerts. As a note, the force value can be set up so that it will cut with different values in the X and Y directions as shown here. This feature will be discussed later in this lesson. The last, acceleration, currently at 4, indicating how quickly the cutter speed is reached after the cutting tool changes direction. Next is to configure the current condition settings by pressing the Condition/Test key. In this menu, we are given different settings: condition number, tool type, speed, and force. Notice for this menu there are also 4 pages of options. If we press the up or down arrow key, we can cycle through the pages of other condition settings. In this example, we're going to set a condition for cutting vinyl. First, we need to select the tool type by pressing the 2 key, and this tool menu appears. Pressing the up and down arrow keys cycles through the different tool types. In this case, the type that will be used is the CB15U, which was the tool type already selected. This tool comes standard with the FCX2000. If you are unsure of which tool type is which, check the package it came in. Now that we have selected the tool type, simply press the Enter key to set the tool type. This will bring us back to the Condition 1 settings. We can keep the speed the same, but let's change the force to a value of 20 by pressing the 4 key. This menu is a little different from the tool type menu. Here we are given all the force values for each condition. The top row of numbers represents each of the 8 conditions. The bottom row of numbers represents the force values of each condition. Right now, Condition 1 is highlighted. This means that we can change the force value for Condition 1. We can press the down arrow key to lower it to 20. If we wanted to change the force for Condition 3 here, we can do it on the fly by pressing the side arrow key. For now, we will leave it as is. Let's go back to the 1 for Condition 1. Now that the force is adjusted to 20, pressing Enter sets the value. Once a condition is configured, it should be tested. At the lower right of the display shows 2 different types of test patterns to cut. If the left arrow is pressed, the cutter will cut a single square paired with a triangle. The right arrow key will cut 3 patterns. The first pattern is cut with the current force -1. For instance, the force is set to the value of 20, then the first pattern is cut with the force value of 19. The middle pattern is cut at the current force of 20, and the third pattern is cut at the current force plus 1. In this case, 21. This provides a way to more accurately determine the necessary force value. If you are cutting adhesive-backed media, this may be the pattern you'd want to use until you become more familiar with the operation of the cutter. When cutting thicker materials, one pattern may suffice. Let's press the right arrow. Press the 1 key for force, since that is what we are testing. This will cut 3 patterns on vinyl. For materials with a backing, such as self-adhesive vinyl, once the pattern or patterns are cut, first remove the square in the middle pattern. It should separate from the triangle fairly easily. If not, try the third pattern. If it removes easily, we know to increase the force by 1. When cutting a test pattern on materials you plan to cut all the way through, such as material without a backing, the entire pattern should pop out, leaving clean edges. Don't concern yourself with leaving the triangle. As long as the square pops out easily, then the cutting force is set correctly. Once you understand how to adjust a condition, the next step is to configure the other conditions. Let's switch to a different condition. This is easily done by pressing the 1 key for Condition. Here we can switch to a different condition by pressing the up or down arrow key. This will cycle through the 8 conditions. Let's cycle through to Condition 2 and configure Condition 2 for cutting chipboard. We'll set the tool to CB15U. The speed to 35. And the force to 20. Press Enter to set the values. Finally, let's set Condition 3 for creasing. Press the 1 key to change the condition. Next, press the up arrow and switch it to Condition 3. press Enter, and adjust the setting for creasing. We'll set the tool to CT002. We need to set the creasing pressure relatively high, so before we set the force, we have to assign condition 3 to tool holder 2. This way we can take advantage of its higher force. Press the up arrow key once to access the next page of settings. To assign condition 3 to tool holder 2, we need to press the 2 key for Assign Tool. Once again, we have this matrix similar to when we changed the force, except the bottom row of numbers represent which tool holder is assigned to each condition. A 1 represents tool holder 1, and a 2 represents tool holder 2. Since the highlighted condition is set to 3, we can press the up or down arrow to set the value to 2, representing tool holder 2, and press Enter. Now we can change the rest of the condition settings, including the force, now that it can be set to a higher force value of 70, and set the speed. To get back to the ready status, press the Condition/Test key. When the cutter status is ready, the quickest way to switch conditions is simply by holding the Enter key and selecting the appropriate condition from the pop-up window. Beside each condition, there is a key number or arrow key showing us what to press to switch to that condition. Keys 1 through 4 will switch to conditions 1 through 4 respectively, or press one of the arrow keys for conditions 5 through 8. Let's press the 2 key to jump to condition 2. As you will learn in later lessons, switching conditions can also be done completely from the Cutting Master 4 plugin. Configuring conditions may seem tedious at first, but in the long run it can save you a lot of time and hassle. For instance, each time you switch materials, instead of taking the time to configure the cutter to the best setting each time a new material is loaded, it's simply a matter of switching to a condition that has been perfectly configured to that material. Add to this the idea of assigning conditions to individual paths within the software, and it will make you even more productive. Selecting the appropriate condition from the pop-up window. Beside each condition, there is a key number or arrow key showing us what to press to switch to that condition. Keys 1 through 4 will switch to conditions 1 through 4 respectively, or press one of the arrow keys for conditions 5 through 8. Showing us what to press to switch to that condition. Keys 1 through 4 will switch to conditions 1 through 4 respectively, or press one of the arrow keys for conditions 5 through 8. Let's press the 2 key to jump to condition 2. As you will learn in later lessons, switching conditions can also be done completely from the Cutting Master 4 plugin. Configuring conditions may seem tedious at first, but in the long run it can save you a lot of time and hassle. For instance, each time you switch materials, instead of taking the time to configure the cutter to the best setting each time a new material is loaded, it's simply a matter of switching to a condition that has been perfectly configured to that material. Add to this the idea of assigning conditions to individual paths within the software, and it will make you even more productive. Tangential mode is a cutting method listed in the condition settings used to provide cleaner corners for thicker materials. When enabled, the cutting blade is lifted up on each corner, swiveled to the next direction, then comes down with the blade positioned in the direction of the next line segment. Tangential mode is a condition setting, which you may choose to enable or disable for each condition based on the material you plan to use. To turn on tangential mode for a specific condition, press the Condition/Test key. Recall that this will allow us to adjust the setting for each condition. If we press the up arrow key to display the second page of settings, we can then press the 3 key for Tangential Mode. Once again, we are showing the matrix of the 8 conditions, with the bottom row indicating whether thick is enabled or disabled for each condition. A dashed line shows that Tangential Mode is disabled for that condition. A 1 represents that Tangential Mode is enabled for that condition and that it is set to Mode 1. A 2 represents that Tangential Mode is enabled and is using Mode 2. What is the difference between Mode 1 and Mode 2? When Tangential Mode is enabled, it overcuts the corners. In other words, the blade will cut past each corner, thus providing sharper corners. Mode 1 will overcut each corner of the design, whereas Mode 2 overcuts only the start and end points. Mode 1 is best used for thicker materials such as Sandblast Rubber or corrugated packaging. For thin materials, such as cutting intricate lettering or graphics on self-adhesive vinyl, Mode 2 can be used since overcutting is not necessarily needed. In this case, we'll press the 1 key since we are cutting chipboard. Finally, press Enter to apply the changes. When using Tangential Mode, the amount of overcut can be adjusted depending on the material being cut. While we are still in condition settings, if the 4 key is pressed, this will allow for the overcut lengths to be set. Pressing 2 allows us to set the distance the cutter starts each cut line before the intended start point of the line segment. Whereas pressing the 3 key will allow us to have the cutter extend the cut line beyond the intended endpoint of the line segment. Generally, the default values are sufficient for most materials, but cutting thicker materials may require the extension of each cut line. One improvement of the FCX2000 is its expanded creasing capabilities due to its high rigidity Y-bar, optimized algorithms, and a new creasing tool providing smoother creasing. Graphtec's newest creasing tool, the CT001, has been completely redesigned to produce cleaner crease lines and the ability to create curved crease lines, which allows for more flexible and creative packaging design. In this section, we will cover the different creasing tools available, as well as some of the options available for creasing. There are 2 types of creasing tools. The first type is for creasing thick cardstock, such as chipboard. These crease tools use a small rolling bar at their tips to crease the material. The second type of tool is for corrugated packaging materials. These creasing tools use a wheel to crease the material. Generally, both tools need high force to work properly, so it is best to load them in Tool Holder 2, which has higher downforce. Installing a creasing tool is similar to installing a blade holder tool. Loosen the thumb screw, insert the creasing tool, make sure the tool is seated all the way to the bottom, and then tighten the thumb screw, making sure the top of the bracket is over the rim of the crease tool. The next step is to configure a condition for it. In this example, since we will be using chipboard, we have already configured condition 2 for cutting and condition 3 for creasing chipboard. To save time, we've already configured the speed and force. Let's go ahead and configure the other settings for using a creasing tool by cycling to page 3 of 4 of the condition settings, and press the 1 key for crease conditions. Here are options directly affecting the crease line. The first option, Mode, has different types of crease lines. Let's press the 2 key, and here we can cycle through modes 1 through 3. The difference between each mode is simple. Let's say this is the intended line data that is to be the crease line. If mode 1 is chosen, a single crease line is placed or plotted on the intended line data. If mode 2 is chosen, crease lines are placed or plotted on either side of the intended line. If mode 3 is chosen, the crease line is placed or plotted on the intended line pattern, as well as plotted on each side of the intended line pattern. Using one of these two modes provides a rounded look to the crease lines. Spacing determines the space between the two crease lines when modes 2 and 3 are being used. Let's press the Escape key. To adjust the spacing, the right arrow key can be pressed, which will bring up this window where the up and down arrow key changes the spacing. Let's go back by pressing Escape. Repeats tells the cutter to make additional passes of crease line to the number indicated. By pressing the 3 key, we can increase the number of repeats we want for each crease line. Let's go back by pressing Escape. The Start option determines the length of the line. The higher the number, the shorter the crease line will be, creating a gap at each end of a line segment. Once all settings are adjusted to your preferences, press Enter to apply the values. Of course, the next step is to test the condition. This is done by pressing the left arrow key, and the cutter will plot a pattern using the current condition settings. As seen here, the creasing tool is doing the repeats that we specified earlier. This may be sufficient. However, we recommend doing further testing by sending a design with crease lines using a sheet of the material you plan to process. The next section will cover some of the commonly cut materials for the FCX2000. For each material, we will supply the tools needed, as well as some suggestions when cutting them. Please keep in mind that these values and settings provided by Graphtec are to serve only as guide points, since each material's specifications can vary greatly depending on its manufacturer. Graphtec offers a multitude of blades and tools for use with different types of media you may be using. This diagram can also be found on Graphtec's website to review the details of each tool and blade. The general steps to take prior to cutting each material are: first, set up the blade you plan to use. Adjust and test the blade length of the blade tool holder. Adjust the tool head to the correct height if necessary. Configure a condition for cutting the material. And finally, perform a test cut. The items that are needed to cut Sandblast Rubber are the CB15U-K30 that comes standard with the FCX2000, and the pen adapter and pen. The reason we suggest using the pen tool with Sandblast is because once the pattern is cut, it is difficult to see where the cut line is when it is time to weed the design. We suggest using the pen to first plot the pattern, and then follow up with a second pass using the cutting tool. When a pattern is plotted with a pen and then cut, it provides an easy way to distinguish the cut lines. Being a thicker media, Tangential Mode should be enabled for that condition. When cutting chipboard or corrugated packaging material, the CB15U can be used, and for thicker materials, the CB15U-K30. Both come standard with the FCX2000. Graphtec offers a larger blade, the CB30UC. If you plan to order this particular blade, a different blade holder must also be ordered. As mentioned earlier in the section on creasing, Graphtec offers 4 different creasing tools. The first two, the CP001 and the CT001, are rollerball types that are meant to be used only with chipboard, and the roller wheel type for corrugated material. When configuring the conditions, make sure Tangential Mode is enabled using Mode 1. When cutting corrugated materials, it may be suitable to enable switching XY force options. This allows for separate force values for the X or horizontal direction and the Y, vertical direction. To enable this option, press the pause menu key, the down arrow key for advanced options, the up arrow key for the next page of options. Press the 1 key for switching XY force option, the 1 key again to enable it, the Enter key to apply the option, and lastly, press the pause menu key to place the cutter in ready status. When changing the force, there will be 2 values to adjust for both the X and Y directions.